Welcome to Chapter 5, Getting Started with Python. In this chapter, we make the exciting leap from designing algorithms on paper to writing real code. Python is one of the most widely used programming languages in the world today. Computers only understand machine language made up of zeros and ones. Since writing in binary is impractical for humans, we use high-level languages like Python that are closer to English. A language translator then converts our code into machine language. There are two types of translators: compilers and interpreters. A compiler translates the entire program at once before running it, while an interpreter translates and executes one statement at a time. Python uses an interpreter, so errors are caught immediately line by line. Python has several powerful features. It is free and open source, highly portable across Windows, Mac, and Linux, and easy to learn due to its clean, readable syntax. Python is also case-sensitive, so the word number and number are treated as completely different identifiers. Python can be used in two execution modes. Interactive mode lets you type and run one statement at a time directly at the prompt, which is great for quick experiments. Script mode lets you write a full program in a file and run it all at once. In interactive mode, you see the three greater than symbols, the Python prompt. You type an instruction and press enter, and the result appears immediately. This mode is perfect for testing small snippets of code, but cannot save your work for later use. Script mode is used for writing complete programs. You write your code in a file saved with the .py extension, then run it using IDL or from the command line. This is the approach used in professional software development. Python has a set of reserved words called keywords that have fixed meanings in the language. You cannot use these as variable names. Examples include true, false, if, else, for, while, break, and return. Python is case-sensitive, so these keywords must be written exactly as shown. Identifiers are the names we give to variables, functions, and other entities in our program. An identifier must start with a letter or underscore, cannot start with a digit, cannot be a keyword, and cannot contain special symbols like the @ sign or hash. A variable is a named memory location that holds a value. In Python, you create a variable simply by assigning a value to it using the equals sign. For example, writing price equals 987 creates a variable named price and stores the number 987 in it. Comments are lines in the code that the interpreter ignores completely. They are written using the hash symbol and are meant for human readers to understand the code. Good commenting practice is essential when working in teams or revisiting code after a long time. In Python, everything is an object. Every value, whether a number or a string, is stored as an object in memory. Each object has a unique identity that can be checked using the ID function. Two variables pointing to the same value will often share the same identity. Python supports several numeric data types. The int type stores whole numbers like 5 or -12. The float type stores decimal numbers like 14.23. The complex type stores numbers with a real and imaginary part, such as 3 plus 4j. Boolean data type has only two values, true and false. It is a subtype of integer, where true equals 1 and false equals 0. Booleans are fundamental for writing conditions in if statements and controlling the flow of a program. Sequence data types store ordered collections of elements where each element is accessed using an index starting from 0. Python has three main sequence types: strings, lists, and tuples. Each serves a different purpose in storing and organizing data. A string is a sequence of characters enclosed in single or double quotes. Strings are used to store text data like names, messages, or sentences. You cannot perform arithmetic on strings, but Python provides many powerful string manipulation operations. A list is a mutable, ordered collection of elements enclosed in square brackets. Lists can store elements of different data types together, including integers, floats, and strings. You can add, remove, or change elements in a list after it has been created. A tuple is similar to a list, but is enclosed in parentheses and is immutable, meaning its elements cannot be changed after creation. Tuples are typically used for data that should remain constant, such as coordinates or fixed configuration values. A set is an unordered collection of unique elements enclosed in curly braces. Sets automatically remove duplicates, making them ideal for operations like finding common elements between two groups or checking membership efficiently. The none type represents the absence of a value. It is not the same as 0 or false. None is commonly used when a variable needs to be declared before a value is available, or when a function does not return any result. Dictionaries are a mapping type that store data as key-value pairs inside curly braces. Each key is unique and maps to a specific value. For example, a dictionary could store a student's name as the key and their marks as the value, enabling very fast lookups. One of the most important concepts in Python is the distinction between mutable and immutable data types. Mutable types can be modified after creation, while immutable types cannot. Understanding this affects how Python manages memory and how data is shared between variables. Mutable types, like lists and dictionaries, can be changed in place. If you modify a list, the change happens directly in memory without creating a new object. This means multiple variables pointing to the same list will all see the change. Immutable types, like integers, strings, and tuples, cannot be changed after creation. When you appear to modify an integer variable, Python actually creates a new object in memory. This is why changing one integer variable does not affect another that had the same value. In summary, Chapter 5 introduced us to the Python programming language, including how to run programs in interactive and script modes, the key data types like int, float, string, list, tuple, and dictionary, and the crucial difference between mutable and immutable types. We are now ready to learn how to control program flow.